In this video, I'm not necessarily going to solve all of the series problems, but I am going to talk about how I would do them and maybe give some hints along the way. And maybe some of them I will solve all the way to the end. So this first one, I think I would look at, and I would say that I could rewrite this series as 1 over n to the 4/5, in which case the power is not greater than 1, so this is a p series because it's 1 over n to a power, and it would diverge. Okay. This next one, 5/7 to the n, I would look at and say, well, that is a geometric series. The ratio is less than 1, so this converges. Next, sine squared. Sine squared would be less than or equal to 1, greater than or equal to negative 1. Putting it over 3 to the n, this I would do by direct comparison, really. And I would say, well, 1 over 3 to the n, that's the same as 1/3 to the n. And this has the potential to be even, one. I'm going to write the n on the outside. 1/3 to the n power, and this with the numerator has the potential of being even smaller. This is a convergent geometric series, so this will converge as well. This next one, I would write the comparison limit. I would do limit comparison, and my comparison limit would be 2 over n, looking at the most powerful stuff on top and bottom. So the comparison limit is a divergent p series, and when you actually finished it, you would find out that this diverged as well. When I see factorials, I think ratio test. So I would do ratio test in this one, and I would say that, I would put my work down here. I would do n plus 1 factorial over n plus 1 cubed over n factorial over n cubed. I would do the limit as n goes to infinity. What you're going to find out here is it will have an infinite limit, and this will diverge. But I would do it by ratio test. Whenever I see factorials, I start thinking ratio. The same is true for a mix of exponents and polynomials. So this is another one I would probably do with ratio test, where I would start by doing n plus 1 squared over 5 to the n plus 1 divided by n squared over 5 to the n. I would do the limit as n approaches infinity. Maybe this one I might just finish off here. If I multiply by 5 to the n over n squared, do a little simplifying, this cancels with that. So I end up with n plus 1 squared on the top and 5n squared on the bottom. The limit as n goes to infinity. Now think about this. If you expanded out the top, if you actually expanded this out, the first term would be n squared. So you have n squared over 5n squared for a limit of 1/5, which is less than 1. Always think about expanding those things out. You don't need to worry about the whole thing. You're only worried about the high power, because that's going to help us dictate the limit. So look at n plus 1 squared. First term would be just n squared. Okay, so this will converge. Let's look at a few more. Again, with a mix of a power and an exponent and a polynomial, I would do ratio test on this one. So setting it up as this. Okay, so you multiply by 2 to the n over n. Simplifying, we'll do that. So the limit, n plus 1 over 2n, the limit is 1/2, which is less than 1. So this will converge. Okay. The next one, 1 over the square root of 2n squared plus 3. I would think about maybe some kind of direct comparison with this. Okay, because certainly the square root of 2n squared, well, the square root of n squared, I mean, could you make some kind of, comparison to that, or maybe even 1 over 2n. The important thing is this is a divergent p-series. So you're comparing it, and I think, like I said, I think you're going to be able to find a comparison that works pretty well. This is going to diverge. That's square root of n squared, giving us n. Okay. This one, the perfect time to use ratio test, right? It's 3 to the n plus 1 over n plus 1 factorial. Maybe to save time, I'll just put n factorial, 3 to the n. Limit as n goes to infinity. So this and that, this and that. The limit of 3 over n plus 1 is 0. So this converges. This next one, I would do a limit comparison. My comparison limit would be 1 over n, which is a divergent p-series. And you do the actual comparison, you would find out this diverged as well. This one, I would start by rewriting as n to the 50th over e to the n, and then I would do ratio test. Okay, so I'd have n plus 1 to the 50th power over e to the n plus 1 multiplied by limit as n approaches infinity. So this would go with that. If you expanded out the top, you'd have n to the 50th and a bunch of other stuff. On the bottom, you have e, n to the 50th. So the limit is 1 over e. Again, please make sure you're paying attention to that if you expanded this out, the first term would be n to the 50th. So this will converge. Next, we have a whole thing raised to the nth power, an equation raised to the nth. This is where we use root test. Root test says we look at just the thing inside, the 4n minus 5 over 5n plus 1, and say, does that have a limit as n goes to infinity less than 1? It does. It's 4/5. So think about it like it's geometric. It's something close to 4/5 being raised to a power, and that geometric series would converge. So will this. Our last ones, again, I would think ratio on this one. And you could clean that up a little bit. This will converge. Okay. For this one, I would think limit comparison. My comparison limit would be 1 over n, which is a convergent p-series. So this will diverge. For this one, I would think ratio. And the limit as n goes to infinity. You clean this up, you're going to end up with a limit of 4. So this will diverge. This one, we're going to think root test because it's a whole thing raised to the nth power. So the limit of what is being raised to the nth power is greater than 1. So we have something bigger than 1 being raised to the nth. Think back to geometric because it's the same type of thing. This diverges. For this one, I would think of the nth term test. Because the nth term, n plus 1 over n plus 4, that limit, just the limit of that sequence as n goes to infinity, is 1. So we keep adding 1 over and over again, so by the nth term test, this diverges. Last one, I would think limit comparison. Okay, and it's because it's just a number over a polynomial. My comparison limit, 1 over 2n, which is a divergent p-series. and you do the comparison, and it would diverge. So we've got a number raised to the nth power. Think geometric. When you've got 1 over n to a power, think p-series. When you've got exponents mixed with other things, factorials or polynomials, think ratio test. When you've got polynomials all over polynomials, think limit comparison. When you've got a function raised to the nth, think root test. So these are all the tests that aren't dealing with alternating kind of put together.